Hello everybody, welcome into another lesson. So today we are going to talk about shifting and reflecting the tangent and cotangent graphs. So here you have really the full standard equations of your tangent and cotangent functions. So you have the form y equals a tangent of b times the quantity of x minus h plus k, and y equals a cotangent of b times the quantity of x minus h plus k. Well, that a, instead of an amplitude like you had in sine, cosine, secant, and cosecant, in tangent and cotangent you don't really have an amplitude, it's just a stretching factor or a shrinking factor for your vertical. And then you have the b, which if you take pi divided by b, you get your period. Your range for both of these functions is always negative infinity to infinity. That'll never change. Now your domain may change based on your shifts. Now if your a is less than 0, that still indicates a reflection in the x-axis. That's one thing that hasn't changed from the other four functions. If you have a negative a, that indicates a reflection. So that's one thing to note. Now that x minus h, if you set that equal to 0, that tells you your horizontal shift, whether left or right. If you get a positive number for x, it'll be shifting right that many units. If you get a negative number for x, it'll be shifting left that many units. And that plus k is a vertical shift. So if it's plus k, it's going to go up that many units. If it's minus k, it'll go down that many units. So let's get started on some examples. And I'm going to keep our handy 45, 45, 90 triangle up there, which will greatly aid us. These are very useful to have. Alright. Whoops, I can keep the range. I don't know why I erased that. That's kind of important, but alright, there we go. So let's get started on the first one here. Y equals negative 1 plus the tangent of 2x. Alright, so this isn't so bad. Y equals negative 1 plus the tangent of 2x. Well, look at your b coefficient. The coefficient on the x, that's 2, right? So you're going to find your period, you got your b equal to 2. So take that pi divided by the absolute value of 2, which would give you a period of pi over 2. So we can go ahead and plot all these now. There's pi over 4. Here's 3 pi over 8. In between there, here's pi over 8. So now I know which way I need to go in the negative direction. Negative pi over 4. Negative 3 pi over 8. Negative pi over 2. Alright, so I have two full periods. Now, let's look at something here. We have a negative 1 plus the tangent of 2x. What does that mean? We have a vertical shift down 1 unit. So we do have a vertical shift down 1 unit, which will not affect our range since it's negative infinity to infinity, but it's going to affect certain values at certain points. So let's go ahead now and let's see. We don't have any horizontal shifts because there's no plus h inside the parentheses. So that's not going to change our asymptotes, but we need to figure out our asymptotes, figure out what our domain is. Alright, so if I put in pi over 4 for x, I would get the tangent of pi over 2, which is undefined, right? So I'm actually going to have a vertical asymptote at x equals pi over 4. Alright, and then what about negative pi over 4? If I put in negative pi over 4, that would give me the tangent of negative pi over 2, which is also undefined. So I have a vertical asymptote at x equals negative pi over 4. And those should really be my only two asymptotes. So my domain is all reals except x cannot equal odd multiples of pi over 4. Alright, so there's my domain. Now we can go ahead and start graphing. So if I put in 0, what's the tangent of 0? That's 0, but then you have that minus 1. I'll actually be at 0, negative 1. Alright, let's put in negative pi over 8. If I put that in, I'll get the tangent of negative pi over 4, which is negative 1, minus another 1 is actually negative 2. If I put in pi over 8, I'll get the tangent of pi over 4, which is 1, minus 1 is 0. So there's what my graph is going to look like with everything shifted down 1 unit. So still my range is negative infinity to infinity, I just have certain values that are shifted down 1 unit. That's the only difference. Now what if I put in pi over 2? Well, I would get the tangent of pi, which is going to be 0. Then I subtract 1, that would give me negative 1. Now let's say I put in 3 pi over 8, that would give me the tangent of negative 3 pi over, or give me the tangent of 3 pi over 4, which is negative 1 minus 1, that's negative 2. So here's what I'm looking at for my graph. And then let's put in negative pi over 2 for x. I would get the tangent of negative pi, which is 0, minus 1, that's also negative 1. I put in negative 3 pi over 8, I get the tangent of negative 3 pi over 4, which is 1, minus 1 is 0. So my graph is going to come up like that. So I just have a period of pi over 2 with everything shifted downward 1 unit, but my range hasn't changed. So that's what this graph looks like transformed. Now you guessed it, we're going to do the cotangent of this. So let's do that real quick. Figure out what's going to happen with the cotangent. If I could quit dropping stuff, that would be amazing. Maybe someday I will, but here's pi over 4. Let's get 3 pi over 8 back on the map. Here's pi over 2, perfect. All right. Now, definitely my domain's about to change because we're about to be dealing with the cotangent instead. So, we're going to do y equals negative 1 plus the cotangent of 2x. Well, my b is still 2. To find my period, I take that pi over the absolute value of 2. I get a period of pi over 2. That much stays the same. My range is still negative infinity to infinity. That minus 1 still indicates a vertical shift down 1 unit. But let's look for the domain of this cotangent function. So if I put in 0, well, the cotangent's undefined at 0, so definitely we're going to have a vertical asymptote at x equals 0. Now what if I put in pi over 2? That would give me the cotangent of pi, which is also undefined. So we are going to have a vertical asymptote at x equals pi over 2. And then if I put in negative pi over 2, that would give me the cotangent of negative pi, which is, again, undefined. So vertical asymptote at x equals negative pi over 2. Alright, so we've listed our asymptotes, so that means our domain is going to be all real numbers except x cannot equal integer multiples of pi over 2. Alright, so that's my domain. X cannot equal integer multiples of pi over 2. Alright, so I think we're ready to graph at this point. So let's put in pi over 4. That would give me the cotangent of pi over 2, which is 0 minus 1 would actually give me negative 1. Now let's put in pi over 8. That would give me the cotangent of pi over 4, which is 1, minus 1 is 0. If I put in 3 pi over 8, that would give me the cotangent of 3 pi over 4, which is negative 1 minus 1 turns into negative 2. So now I can go ahead and graph this. So there's the first period. Now let's put in negative pi over 4. That would give me the cotangent of negative pi over 2, which is 0 minus 1 is negative 1. Let's put in negative pi over 8. That would give me the cotangent of negative pi over 4, which is negative 1 minus 1 is negative 2. And then, whoops, I went off a little bit. Here we go. Let's say I put in negative 3 pi over 8. That would give me the cotangent of negative 3 pi over 4, which is positive 1 minus 1 is 0. So let's go ahead and graph this bad boy. And there you have it. There is your shifted, translated cotangent graph. And I got 2 more of each. Next one is going to be pretty cool. What do we got here? Alright, so we have y equals 2 minus the tangent of x plus pi over 2. This is where your a matters. The coefficient on the tangent's negative 1. So we have that a equals negative 1. That indicates a reflection in the x-axis. So you're going to see that this is actually going to start to look more like the cotangent since it's reflected. So we have that negative a. We're going to have a reflection in the x-axis. Now let's look at b. What's the coefficient outside the parentheses? It's just 1, right? B equals 1. So our period's going to be pi over that absolute value of 1. We have a period of pi. So a pretty normal period this time. We just have pi 1, 2, 3, 4, 5. Here's pi over 2. Here is going to be 3 pi over 4. Here is going to be pi over 4. Alright, here's negative pi over 4. Here's going to be negative pi over 2. Negative 3 pi over 4. And then we got negative pi. Alright, so there's 2 full periods. Now, let's look at what our shifts are. Look inside your parentheses. You have x plus pi over 2, right? That is indicative of a horizontal shift, and it's a horizontal shift left pi over 2 units. So we have a horizontal shift left pi over 2 units. So this is going to affect our asymptotes as well. And then we have a plus 2 on that, so we also have a vertical shift up 2 units. So we have a horizontal shift, a vertical shift, and even a reflection. So we got everything going on. Alright, so let's think about our domain here. This is really going to affect our domain. The range stays the same, negative infinity to infinity. That's not going to change, but let's look at our normal, let's look at all the normal asymptotes for the tangent function. Normally you have pi over 2, right? Because your tangent will be undefined there. But if you add pi over 2, what do you get? You get the tangent of pi where it is defined, it's just 0. Now, let's go back to 0. So what if I put in 0, I'll get the tangent of pi over 2, which is undefined. So actually, x equals 0 is going to be a vertical asymptote. Now, if I put in pi, I would get the tangent of 3 pi over 2, which is also undefined. So I'm going to have a vertical asymptote at x equals pi. So a very interesting thing has just occurred. And then if I put in negative pi, I'll get the tangent of negative pi over 2, which is undefined. So I'm going to have yet another vertical asymptote at negative, x equals negative pi. So in this case, my domain is all real numbers except x cannot equal integer multiples of pi. This is really starting to sound more like a cotangent graph, isn't it? So there's my domain. Using all this information now, we can proceed to graphing. So let's take pi over 2 for x, put that in, that would get the tangent of pi, which is 0. Then plus 2, that'll actually put me at 2. Now what about pi over 4? If I put in pi over 4 for x, that would give me the tangent of 3 pi over 4, which is negative 1. But I have to negate that negative 1 because I have a negative sign. I'll get a positive 1 plus that 2 is 3. And then if I take 3 pi over 4, I would actually end up getting 5 pi over 4 for my tangent. So the tangent of 5 pi over 4 is positive 1, but I have to negate that. So I'd end up getting negative 1 plus 2 would be 1. So here's going to be my graph. So you see what I'm saying? With all the reflecting and shifting going on, this is really starting to look a lot like a cotangent graph. Even though it's technically tangent, it looks very cotangent. So very interesting how these can be manipulated. Now let's take negative pi over 2. That's going to give you the tangent of 0, which is 0, plus 2, that's 2. Let's take negative pi over 4. That would give you the tangent of pi over 4, which is 1. You negate that 1 and add 2, you'll get positive 1. And then let's take negative 3 pi over 4. That would give you the tangent of negative pi over 4, which is negative 1. But you have to negate that negative 1. So it's positive 1 plus 2 is 3. So here is your graph. So with the reflecting, with the shifting, and all of that, it behaves like a cotangent graph instead of a tangent. In fact, the asymptotes are even the same as a cotangent function graph. So it looks almost identical to a cotangent graph instead of a tangent. Now, a curious thing's going to happen when we do the graph of the cotangent of this instead. So we will proceed to do that. Let me just make those changes I need to make on the graph here to make this a cotangent graph. Alright, so let's see here. Let's turn this into cotangent. Your domain's going to change, that's for sure. So we're given y equals 2 minus the cotangent of x plus pi over 2. In the end, even though this is cotangent, this is going to look a lot more like a tangent graph instead. So this is where the a does matter. That coefficient on the cotangent is negative 1, right? Because you could think of this as 2 plus negative cotangent of x plus pi over 2. So we are still going to have a reflection in the x-axis. Now the coefficient outside the parentheses is still 1. Your period's still pi. That much holds true. You even have a horizontal shift left pi over 2 units. And you have a vertical shift up 2 units. So none of that's changed, but what's about to change is your domain, since we've now gone to the cotangent function. Let's look at normal cotangent domains where it's not defined. Normally 0, right? Normally it's not defined at 0, but we're going left pi over 2. So if I put a negative pi over 2, that's going to give me the cotangent of 0 where the cotangent's undefined. So I'm actually going to have a vertical asymptote at x equals negative pi over 2. Alright, and then let's look at pi over 2. Well, if I put in pi over 2, I get the cotangent of pi, which is undefined. So I'm going to have another vertical asymptote at x equals positive pi over 2. Alright, so there's that, and I think we're ready to proceed. But the domain is clearly going to be x cannot equal odd multiples of pi over 2. So even your asymptote's going to behave like the tangent function. So the domain is all reals except x cannot equal odd multiples of pi over 2. So let's go ahead and put in some values here. Let's put in 0 for x. You really get the cotangent of pi over 2, which we know to be 0, plus 2 would give you 2. Now, what if we put in pi over 4? So pi over 4 plus pi over 2 is actually 3 pi over 4, which would give you negative 1. The cotangent of 3 pi over 4 is negative 1, but you have to negate that negative 1, so positive 1 plus 2 is 3. And then if you put in negative pi over 4, you'll get the cotangent of positive pi over 4, which is 1. You negate that 1, you get negative 1 plus 2 is 1. So now we can go ahead and graph this and see this is really behaving like the tangent function. If you were to look at this, you would think this is the graph of the tangent function. It's just a really shifted cotangent function though. Now, what if we put in pi? So if I put in pi, I'm going to get the cotangent of 3 pi over 2, which is 0, plus 2, that's going to be 2. If I put in 3 pi over 4, I would end up getting 5 pi over 4. Well, my cotangent of 5 pi over 4 is positive 1. I have to negate that 1, and then I add 2, I'll just get 1. So here's how this side's going to look, and then let's come over here. Let's put in negative pi. If I put in negative pi, I'll get the cotangent of negative pi over 2, which is 0, plus 2 is going to be 2. And then let's put in negative 3 pi over 4. I would get the cotangent of negative pi over 4, which is negative 1. I negate negative 1, I get positive 1, plus 2 is 3. So I'll just come up like this, and look at this. This is a cotangent function, but the graph and even the asymptotes behave the exact same as a tangent function. And it's reflected too, which makes it behave like a tangent function instead of a cotangent function. Because with a normal cotangent, it's flipped around. So pretty cool how we can manipulate these graphs of these functions to look like something it's not. I got 2 more, which would be 1 for each function. Now in this one, they kind of really throw the book at you. I'm not going to lie to you, they kind of do. So we're going to figure this out. This one's going to be a little bit of fun. So we have y equals 1 plus 1/2 of the tangent of 2x minus pi over 4. So this one, they're really throwing the book at you here. You have 1 plus 1/2 times the tangent of 2x minus pi over 4. Well, let's establish something here. We know our a is positive, so we don't have to worry about any reflections. Now, what do you notice about the coefficient on the x in the parentheses? Because we definitely have a horizontal shift. In order to have a true b, you have to factor out the coefficient on the x, right? So what this really should say is y equals 1 plus 1/2 times the tangent of 2 times x minus pi over 8. That's really what this should say. X equals 1 plus 1/2 times the tangent of 2 times x minus pi over 8, if you factor out that 2. Now you can get a true b and figure out your true shifts and do all that. So let's figure out your b. That's that coefficient on the parentheses, that's 2, right? So my period is going to be, of course, that pi divided by my absolute value of 2, simply giving me a period of pi over 2. So let's go ahead and label our x-axis here. There's pi over 2. Halfway between 0 and pi over 2 is pi over 4. Halfway between these is 3 pi over 8. Halfway between 0 and pi over 4 is pi over 8. So now we have everything we need here. Negative pi over 8. Negative pi over 4. Negative 3 pi over 8. And then negative pi over 2. Alright, so we have 2 full periods here. Now, we figured out our period, we factored this completely. Now let's look here. We have that x minus pi over 8. If you take that, set that equal to 0, you get a horizontal shift right pi over 8 units. So you have a horizontal shift right pi over 8 units. So this will definitely affect your asymptotes for sure. Now, what about a vertical shift? Well, notice you have 1 plus all this, so you do have a vertical shift too, up 1 unit. You have a vertical shift up 1 unit. Alright, and then we know our range. That's easy. The range is the easy one. That's just negative infinity to infinity. That's not going to change. But what about our domain? This is where it gets interesting. So let's look for everything is shifted to the right pi over 8 units, right? So if let's say we put in pi over, let's put in 0, you would get the tangent of negative pi over 4. That's defined. Tangent of pi over 8, so you would get the tangent of pi over 4 minus pi over 4, that's 0. Now if you put in pi over 4, you'll end up getting pi over 2 minus pi over 4, which would actually give you pi over 4. Again, that's defined, but what if I put in 3 pi over 8? So I'm going to put in 3 pi over 8. I'll get the tangent of 3 pi over 4 minus pi over 4. That's the tangent of pi over 2, which we know is undefined. So I'm actually going to have a vertical asymptote at x equals 3 pi over 8. Now, what if, let's see, let's put a negative pi over 8. So negative pi over 8, if I put that in for x, will give me negative pi over 4 minus pi over 4. That's going to give me the tangent of negative pi over 2, which we know to be undefined. So I'm actually going to have another vertical asymptote at x equals negative pi over 8. So already this graph is going to look pretty uneven, right, with our asymptotes. And again, everything shifted right, pi over 8 units. And that's really all the asymptotes we got. Now, let's put in 0 for x. If I put in 0, I'll get the tangent of negative pi over 4, which is negative 1, right? I'm sorry, I'll get the tangent of negative pi over 4, which is negative 1. Well, what's negative 1 times a half? That's negative 1/2, but if I add 1 to that, I'll get positive 1/2. So at 0, I'm up at positive 1/2. Now let's put in pi over 8. 2 times pi over 8 is pi over 4 minus pi over 4, that's 0. Plus 1 is going to be 1. So pi over 8, I'll have a value of 1. Now, what about pi over 4? If I put in pi over 4, that would give me the tangent of pi over 2 minus pi over 4. So that would, of course, give me the tangent of pi over 4, which is 1, times a half is a half, plus 1, that'll put me at 1.5. Right here. So I've also vertically shrunk this graph. It's going to look a little more elongated than normal. And then for good measure, let's put in pi over 2. That would give me the tangent of pi minus pi over 4. Well, that's going to end up being the tangent of 3 pi over 4, which is negative 1 times a half is negative 1/2 plus 1. That would give me positive 1/2. Then it would just go down like this. Alright, so now let's do negative pi over 4. So that would give me the tangent of negative 3 pi over 4, which would be positive 1, times a half is actually positive 1/2, plus 1 is positive 1.5. Let's put in negative 3 pi over 8. That would give me the tangent of negative 3 pi over 4 minus pi over 4. So that's the tangent of negative pi, which is 0, plus 1 would actually give me 1. The tangent of negative pi over 2, that's going to be the tangent of negative pi minus pi over 4. So that's the tangent of negative 5 pi over 4, which is negative 1. Times the half is negative 1/2, plus 1, that's just 1/2. So there is the graph of all this, shifted to the right pi over 8 units, with a vertical shrinking factor of 1/2, and everything shifted upward 1 unit. So sometimes when you do these shifts, you can get some very funky looking results. And you guessed it, we're going to do the cotangent. So stay tuned for that real quick. We're about to do the cotangent. Let me just go back through and reconstruct where I need to. This is 3 pi over 8. Okay, I just want to make sure I have the right location. And this would just be pi over 2. Okay. Alright, I don't think we need to change much here. Alright, so this time we're going to do y equals 1 plus 1/2 of the cotangent of 2x minus pi over 4. Well, all I had to do is change tangent to cotangent, and we have our factored form already, which is nice. So, yes, your b is 2, giving you a period of pi over 2. I already have that set up on the x-axis, which means we still have a horizontal shift right pi over 8 units. And we also have a vertical shift up 1 unit. Our range is still negative infinity to infinity, but what about our domain? Well, what is a normal cotangent of, what is a normal asymptote of the cotangent? Definitely 0, right? But if I put in 0, I'll get the cotangent of negative pi over 4, which is defined. But what if I put in pi over 8? That would give me pi over 4 minus pi over 4, which would be the cotangent of 0, which is undefined. So I'll actually have an asymptote at x equals pi over 8. Alright, so that means everything should be good from here on. Now, if I put in negative 3 pi over 8, that's going to give me negative 3 pi over 4 minus pi over 4, which is negative pi. Cotangent at negative pi is undefined. So I'll have another vertical asymptote at x equals negative 3 pi over 8. So we have two asymptotes, x equals negative 3 pi over 8, x equals positive pi over 8. So you see how this is weirdly shifted again. Why don't we put in the tangent of the cotangent for 0? So take 0, you'll get the cotangent of negative pi over 4, which is negative 1 times a half is negative 1/2, plus 1 would give you positive 1/2. Alright, now let's take negative pi over 8. That would give me the cotangent of negative pi over 4, minus pi over 4, that would give me the cotangent of negative pi over 2, which is 0 plus 1 is going to be 1. Let's put in negative pi over 4. This would give me the cotangent of negative 3 pi over 4, which is actually then going to end up being, that would end up being positive 1 times a half is 1/2, plus 1 is 1.5. So now we can go ahead and graph this. So there's your first period. Now, let's go further to the right. Now let's do the left first. What about negative pi over 2? So if we did negative pi over 2, that gives me the cotangent of, that's the same as negative 4 pi over 4. So that'd be minus 5 pi over 4. So that's going to be negative 1/2 times, that'd be negative 1/2 plus 1, that'd be positive 1/2. Which would put my graph down like this over here. Alright, now let's go to pi over 4. 2 times pi over 4, so minus pi over 4, that's pi over 4. The cotangent of pi over 4 is 1, times a half is 1/2, plus 1 is, well, 1.5. What about 3 pi over 8? Take that times 2, I'll get 3 pi over 4 minus pi over 4. That'll give me the cotangent of pi over 2, which is going to be 0 plus 1 is, well, 1. Then if I take pi over 2, that would give me the tangent of pi minus pi over 4, so that's going to be 3 pi over 4. Cotangent there is negative 1 times a half is negative 1/2 plus 1, that would give you positive 1/2. So here's how your graph is going to look, all weirdly shifted with the various asymptotes. So that's actually it for graphing trig functions in general. So the goal of graphing these trig functions for the past several lessons has been to help us visualize the range and domain and what they look like, because the next lesson we're going to do inverse trig functions. And having seen it graphically and understanding the domain and range is really going to help you when you get into inverse trig functions. So I hope everyone has a great day. Take care.